Okay, guys, last chapter. This is some fun stuff. The last page of this set of slides is a picture from the stuff in your book, just so you can flip to the last page and refer back to what it is you're learning to get an actual picture of it and how it's created from a conic. All of these things, if you have a cone, and I'm not a good illustrator here. If you have a cone and you slice it straight across, say perpendicular to the axis, if you slice it straight across, then what you're going to see at the edge of the paper is a perfect circle. If you slice in a crooked way, it's like this, and you look at the edge of the paper where you cut it, you'll get what's called an ellipse, which is the second page of the notes here. And if you slice straight up and down, say I take my slice this way, then when you see the edge of the paper, it's actually going to be, I can't do that three-dimensionally, it's going to look like a parabola. So all of these things are called conic sections. If you have two cones, tip to tip, exactly the same. Okay, exactly the same. We have to pretend a lot in this section, the whole chapter actually. And I slice it straight through this way. Then I'm going to get two back-to-back sort of parabola-looking things like that. And in the next video, I'll give you details of how to draw these things. For now, we're just going to talk about just what everything means. And also, I'm going to post a couple of YouTube videos that show some really cool properties of parabolas and ellipses. Okay, so on with it. Here we go. 10.1, your homework is 11 through 47, just every other odd. This should be all review with a little extra salt and pepper in there. When you learned parabolas in pre-calculus, you probably wrote them as y equals x minus h squared plus k. And there may have been some multiplier in front that told you what your vertical stretch would be. And if a was smaller than 1, it would look like you were stretching it horizontally when actually you were just squishing down the y values. So if you set the parentheses equal to 0, x would equal h. And if this is 0, then y equals k. So your center or your vertex is always hk for all of these things that we're going to go over. So in your calculus book, they write a parabola this way, where the k has been subtracted from both sides, and that a is divided, so this a right here would be 1 over 4p. Now notice that this is the vertical one. The x part is squared, so your axis of symmetry runs vertically like the picture here, but you can also go sideways. This is not a function because the graph would look like that, but it's okay. These are very useful things even if they're not functions. So a vertical looks like this one on the paper, where your axis of symmetry runs through x equals h. And let me write that down. The axis of symmetry right here is the line x equals h. So your vertex is on that line, and the y value is k. Plot that point. You know to use from pre-calculus, you can use that coefficient in front of the x squared term to tell you how far up or down to go when you move out 1 in each direction from your axis here, from your vertex, sorry. So if I go over 1 unit, then I'm squaring a 1. If I go backwards 1 unit, I'm squaring a -1, which just gives me +1 again. So A is going to tell you how far the y value changes. If it's positive, it goes up. If it's negative, it goes down. And if you're sideways, positive goes to the right, negative to the left. Simple enough, right? Now, the actual definition of a parabola is the collection of all points equally distant from a fixed point. Here's your focus right here, and this fixed line called your directrix. So you pick any point and you measure the distance perpendicular to your directrix and to the focus. You're going to get the same distance. And when you find all of those points that have equal distances, you end up with a parabola. The way to find the apparently we're finding a forcus instead of a focus. Sorry about that. I'm not changing the notes. I already posted them. So darn it. It's not a forcus. It's a focus. Sorry about that. Okay, the focus is on the axis of symmetry, and the distance from the focus to the vertex is what is this P right here. Okay, usually P is very small, just saying. So let's continue on. The next kind of conic is an ellipse, and again, this should be reviewed from pre-calc 2. The standard form of the equation of ellipse is this right here. The thing you need to focus on is getting that 1. And what you do, the center is what makes this 0 and what makes that 0. So the center is at a HK. You plot the center, and in the x direction, you count out A. Remember, this number is A squared. So you take the square root of whatever that number is, and you're going to go over A and backwards A. And then in the y direction, you're going to go up and down B units. Down B, up B. And then when you connect those dots, you get this shape of an ellipse. If you were to take a board and put a pin at these focus points and put a string around it, hang the string around those focal points and stretch the string as tight as it could go and keep it tight all the way around where it's pulling on those focus points where your pins are. That's how you can draw a perfect ellipse. If A is the biggest number, then your major axis is this way, and that's where your focuses are, your foci. They're on the major axis. If B is the bigger number, then you're going to be shaped vertically, and your focus points will be on the vertical axis. So if A is biggest, your major axis is horizontal. If B is biggest, your major axis is vertical. You will get both types. The homework may ask you to find your focus points. Just pay attention. Are you going up and down or back and forth based on which one of these numbers, A or B, are bigger? And that, remember, you got to get a 1 first. And then you will know once you draw, go ahead and draw your axes, and then whatever C is, that's how far out from the center you go to put your focus points. And you find C with this right here. It kind of resembles the Pythagorean theorem, but don't get stuck trying to figure out what's the hypotenuse or anything. It doesn't work that way. So The big one squared minus the little one squared. It's not always a minus b squared. Sometimes it's b squared minus a. It's the major minus the minor, both squared, gives you c squared. Okay, so in your book, in most textbooks, they always make a the biggest number and b the smallest. And you'll see in the notes here, except for this right here, you'll see that I just associate a with x and b with y, just to keep it simple. And you can tell which one's bigger, so you know which one's vertical or horizontal, which one's, with the major and which one's the minor axes, and whether your guy is vertical or horizontal. Now, the next thing is the eccentricity. This gives you kind of like the character of it. The eccentricity is the ratio of the C to the A. Remember, the A in this case is the major axis. So the distance from the center to the focal points divided by the distance from the center to the vertex on the major axis. Here's your vertical one. So this ratio is going to be less than 1. But if the ratio equals 0, if C is 0, then your focus points are, both of them are right on top of your center, and your A equals your B, because you got a 0 here, and that is a circle. So the eccentricity of a circle, which is a perfect ellipse, is 0. And then as the eccentricity gets bigger and bigger and bigger, your ellipse gets more and more flat and less circular. Okay, now this looks a lot like the same formula as an ellipse, but you see that we have a minus sign here. So with the ellipse, you were adding. Now with a hyperbola, it's like you're taking the two halves, and instead of putting them together, you're putting them back to back, and you get something that looks like this right here. So if the x one is positive, you're horizontal. If the y one is positive, then you're vertical. And you don't know if it's not in this form, you don't know until you get it in that form which one it's going to be. So don't jump the gun. In this case, pay attention to, you got to get ones. I'm just writing A with the X and B with the Y. Our vertices are going to be based on the vertices, meaning the points, whether your axis runs horizontal or vertical, is all dependent on which one of those guys is positive. If this is positive, then you're horizontal. If this is positive, then you're vertical. You'll practice both types in the homework. The ABC relationship is different. In the last one, you are subtracting for ellipses. Now for hyperbolas, you're adding. So your C is the distance, again, from the center, which is not a point inside or on your graph. It's just where you're marking things out. The distance C is from the center to one of the focus points, and it would be the same if you went to the other one. The distance from the center to your vertex, if you're horizontal, is A, and then B is just this distance right here, and it's important because of these asymptotes. Now, in the next video, I'll show you exactly how to do this, but if in this case, this horizontal case, I plotted my center HK. I went out A in the X direction, back and forth. I went B in the Y direction, up and down. And then making these little lines here, I create a box. Once I get my box, I'm going to connect the corners through the center. That gives me asymptotes. Now, in this case, the X thing was positive, so I know my vertices are horizontal through the center. The axis of symmetry is here, and my vertices are horizontal. So here's my vertex. I'm just going to approach the asymptotes and pass through the point. And then the other side, the same thing. Eccentricity is a relationship between C and A. C is bigger than A now, so this is always bigger than 1. Okay? And if this ratio is big, then your parabolas are fat. If the ratio is small, then your asymptotes have closed down. Your B is smaller, and you end up with more skinny hyperbolas. Here's the formula for your focus points. Here's where you find your vertices, but you shouldn't have to worry about this. You should be able to see it when you're graphing. And here you see pictures of all the different things. Remember that a circle is just sliced straight through, and it's just a perfect ellipse. You can take this picture of the ellipse right here and slant that slice however you want it. If it's straight across, you're a circle. The steeper you get, the more skinny your ellipse is going to be. A parabola is just a slice through the open edge, and you can trace where it cuts right there. And then hyperbolas are straight up and down slices that cut through both cones in a straight way, so they back up to each other.